Nothing quite matches the tension of bringing down a towering oak. First, wire ropes were secured high up in the tree, off-camera, anchored to two classic AEC trucks, the Matador and the Militant. A crew armed with multiple steel chainsaws carved a notch at the base, creating the controlled weak point. With a coordinated pull, the trucks brought it down cleanly. You could hear the cracking before the fall. It was exhilarating. The timing had to be flawless, too early or too late, and the tree might twist unpredictably. Even the wind was taken into account before making the final pull. Their strength and precision turned a hazardous task into a controlled demolition, grounded in old-school mechanics and a bit of daring teamwork. This timber truck navigates a steep descent through Rio Verde, Chihuahua, an unforgiving route for any vehicle. Fully loaded and riding low, it inches downhill with calculated braking and precise wheel control. The tires bite into loose gravel, resisting every slide. Watching that weight shift through sharp curves? It's a raw display of gravity, friction, and driver nerve. This chainsaw isn't just big, it's a powerhouse. The Stihl MS-881, paired with a massive 1.7-meter bar, delivers 8.7 horsepower, making it one of the strongest production chainsaws available. In this demo, it effortlessly slices through thick timber, the kind that would bog down lesser machines. Just hearing the rev of that engine sends a shiver down your spine. The operator begins by positioning the bar for a horizontal cut, keeping the saw steady while managing the torque. Despite its weight and bar length, the Mississippi 881 handles with surprising balance thanks to its well-engineered frame. As the chain bites into the wood, chips fly fast, clean, consistent, and forceful. The cut is smooth, the power is relentless. You can almost smell the sawdust and feel the vibration through the screen. This machine is built for professionals dealing with large hardwoods, wind-thrown trees, or milling massive trunks. Watching it glide through dense oak like it's soft pine is oddly satisfying. For those in heavy forestry or sawmill work, tools like this aren't just useful, they're essential. Nothing about this saw whispers, it roars. This process creates thermobonded non-woven mats using coconut fiber and powder resin, ideal for insulation and automotive interiors. Fibers are opened, blended, and evenly scattered across the belt before entering the bonding oven. The evenness is unreal. Each layer feels engineered. It's light, but the build quality speaks volumes. This system is built for one purpose: compressing loose copper chips into dense, transportable briquettes. It drastically reduces storage volume, making handling and logistics far more manageable. It starts with a conveyor, feeding raw copper swarf into a shredder, reducing bulky chips into uniform fragments. These pass through a hopper and are directed into the briquetting press. High-pressure pistons compress the metal into solid cylinders with consistent density and minimal voids. Dust is extracted continuously to keep the system clean and prevent contamination. Finished briquettes exit the press and are collected in bins, ready for melting or resale. The consistency is impressive. Each piece feels like engineered copper, not just scrap. This setup, installed by CMO in Milan, runs with minimal human intervention thanks to its automated flow. It's efficient, mechanical, and oddly satisfying to watch. Turning tangled waste into uniform briquettes like this doesn't just reclaim value, it restores order. Making a plywood cable reel might look simple, but every step counts. It all begins with large plywood sheets, laid flat and trimmed into perfect circles, using a router mounted to a rotating jig. This rotating base ensures uniformity across all reel sides, which is crucial when the cable will be spun or pulled at high tension. Even the initial plywood selection affects the final strength. Thicker sheets prevent warping under heavy load. After the discs are cut, the team drills evenly spaced holes around the perimeter. These holes aren't just for looks, they're for securing the reel's core and allowing smooth cable winding. Each hole placement is marked manually, then drilled using a vertical press to maintain precision. You can almost hear the satisfying hum of every drilled pass. Watching the team move in sync, each person with a clear task, reminds you how refined manual labor can be. Next comes the central core. Long, cylindrical wooden blocks are cut and pre-drilled to serve as spacers between the discs. These form the skeleton of the reel. The side discs are aligned and temporarily fastened, keeping the frame square for the next step. Then, horizontal braces are inserted from the outside and tapped in using a mallet until snug. It's not just assembly, it's quiet problem-solving with every measured strike. The sound of wood-on-wood contact, as each beam is driven in, adds a rhythmic pace to the build. These outer braces help the reel resist twisting and collapsing under load. It's a purely mechanical structure. No adhesives, no metal reinforcements, just smart joinery and confident strikes of the hammer. Once the full structure is assembled, it's checked for squareness and firmness. The builders lightly tap the edges and joints, listening for gaps or shifts. If something's off, they adjust it by hand before final tightening. By the end, what started as raw plywood and timber has become a sturdy industrial tool. It's strong enough to carry long spools of cable, light enough to transport easily, and repeatable for batch production. These are the kinds of skills that keep utility lines running and construction sites stocked, all built on the strength of simple materials and sharp craftsmanship. This logging truck climbs out of the narrow dirt trails of Aido San Francisco with a full load of timber on its back. The road barely fits its width, with uneven terrain and loose soil pushing every tire to its limit. The suspension rocks under the shifting weight as the driver balances throttle and clutch with precision. You can feel the tension in every uphill pull. It's grit against gravity. Mud sprays from the wheels as traction slips and recovers. There's no margin for error. One wrong move and it's stuck for hours. But this isn't the truck's first time through this maze. It lurches, steadies, and pushes forward like it knows the way. Each log sways with the climb, stacked high and heavy. That the driver can maneuver such a load through this kind of trail? That's skill, plain and simple. It's not just transport. It's control, experience, and a whole lot of nerve. Crafting a wooden rowing boat is more than carpentry. It's a precise, layered journey. It starts with the inner skeleton. A sturdy keel beam and multiple frames are assembled to shape the backbone of the vessel. These curved ribs define the profile of the hull and must be positioned with millimeter accuracy. You can already feel the care in each alignment. Each frame is double-checked for squareness and verticality before any skin is applied. Temporary braces are added at this stage to keep everything rigid during the lamination. Once the base structure is fixed onto a strong building jig, craftsmen begin cold laminating the hull. Thin veneer strips are laid diagonally across the frames in multiple layers. The first layer is often laid dry to test fit before glue is introduced. Each strip is carefully coated with glue and pressed into place, forming a seamless, curved skin that wraps tightly around the mold. Workers apply pressure manually first, then follow up with belts and blocks for consistent tension. The crisscross pattern of the veneer layers isn't just beautiful, it adds serious structural strength. Before the glue cures, excess is wiped off to prevent hardened ridges. After lamination, the hull is left under tension for hours to cure completely. The curing time can vary depending on humidity and temperature inside the workshop. With the outer shell complete, it's time for interior work. Seat supports, foot braces, and bulkheads are installed, all precisely fitted to ensure balance. The alignment of the foot brace is critical. It affects leg drive during rowing. Even a few millimeters of misalignment can affect how the rower transfers power. You can see the builder checking every joint by hand, no gaps allowed. A lightweight wooden floorboard is sometimes installed for better footing and drainage. The deck edges are reinforced with laminated wooden rails, bent along the boat's curvature. These add rigidity while doubling as grip points. Steam or hot water is often used to soften the wood before bending. Even the oar locks are installed with care, aligned for optimal rowing angle. The symmetry here matters. Uneven placement can throw off the entire rowing rhythm. Nothing is rushed here. Every screw and joint is deliberate. Sanding follows, where the entire boat is smoothed inside and out. Edges are rounded, surfaces cleaned. Fine grit is used in the final passes to prepare for varnish. Then comes coating. Multiple layers of varnish are applied not just for beauty but to protect the wood from moisture and wear. Between each layer, light sanding ensures a smooth buildup. The glossy finish catches the light in a way that almost makes the boat glow. Finally, metal fittings are added: handles, anchor points, rudder hardware. Each piece installed without disrupting the boat's flow. The boat is then flipped upright, inspected one last time. The lines are sleek, the weight balanced. You'd never guess such strength could come from layers of thin wood. By the end, what started as planks and glue becomes something almost alive, responsive, hydrodynamic, and crafted for quiet adventure. Watching it glide into the water for the first time is a reward in itself. It's not just about building a boat, it's about building something that moves with the person inside. In a world of fast production, this kind of patient craftsmanship stands out. Stretch forming shapes aluminum extrusions by clamping each end and pulling them under tension over a die. This process eliminates wrinkles and springback while ensuring precise curvature. You can hear the metal yield gradually as it conforms. That slow, controlled bend. It's so satisfying to watch. It's not brute force. It's finesse applied through tons of pressure. The Pezolato plant roars to life as massive logs enter the TM1200 cutting unit. Right away, you sense its power. This machine handles logs up to 1.2 meters in diameter, with a 1.6 meters chainsaw bar slicing through thick trunks like butter. The operator aligns each log on the conveyor. Accuracy here means clean, consistent cuts. A hydraulic clamp grips each log tightly before the saw engages. The vibration runs deep through the floor as the chainsaw bar completes each aggressive stroke. Once the cut is complete, a pusher arm gently moves the log toward the next station. Once cut to length, logs move to the TB900 splitter. This electric-powered beast delivers up to 40 tons of splitting force, enough to cleave 90 centimeters rounds into manageable firewood. Blocks between 250 and 500 millimeters are standard. Smaller cuts down to 70 times 70 millimeters are also possible. The precision here ensures uniform pieces ready for stacking. Watching that wedge split the wood with brute consistency is oddly compelling. Some logs are rotated slightly for optimal alignment before splitting begins. Production runs at impressive pace. In a single 8-hour shift, it can output about 150 BCM of firewood. The automatic feed keeps the process flowing with minimal operator input. The sound of logs snapping and wood chips flying fills the air, almost like applause for raw efficiency. A conveyor system continuously removes finished pieces, reducing downtime. Technicians monitor motor load and conveyor speed in real time, optimizing flow and preventing jams. Seeing them adjust settings mid-shift shows how hands-on and responsive the process is. Control panels glow with data, current, torque, cycle count, proof this isn't just brute force but smart engineering. The system adapts automatically to log size variations, adjusting speed and feed force. Safety is built in. Guards cover the chain bar and splitter zone. Sensors halt the system if anything misaligns. Flashing lights and audible alarms warn of any obstruction or overload. By the final tally, raw logs have transformed into neatly cut firewood, uniform, dense, ready for sale or winter stacking. The scene concludes with tidy piles waiting for transport. It's not just about wood production. It's about reliable output, efficiency, and craftsmanship allied with heavy-duty hardware. This is how pulp becomes paper on an industrial scale. Logs are debarked, chipped, and cooked to break down lignin, releasing the pulp. After bleaching, it's dried into sheets or pumped forward for papermaking. The pulp mixture is sprayed onto a fast-moving filter, where fibers align into wet paper sheets. Powerful rollers squeeze out moisture, and heated cylinders dry the sheet at around 100 degrees Celsius. You can see steam rising. This part works hard. In finishing, the paper is coated, dried again, and rolled into wide reels up to 8.6 meters across. Then it's cut and packaged for shipment. Every step is precise and intentional. Watching raw wood transform into clean, white sheets like this, That's industrial alchemy in action. This vintage Kenworth rolls out of the woods, stacked high with fresh-cut logs. The 12V71 Detroit growls through dual stacks, echoing off the trees like it owns the trail. Axles flex under the weight, but it keeps crawling forward, steady and sure. There's something timeless about this scene: steel, torque, and timber. No sensors, no autopilot. Just raw machine and road. Watching it move feels like a tribute to everything old-school trucking stood for.